right now without thinking about it. You are trusting your life to a thin black surface you have never once looked at closely. You drive across it at 70 miles an hour. You walk over it half asleep. And it holds. Every time. But the thing under your tires is not solid, and it was never meant to be. It is one of the most quietly brilliant machines humans have ever built. And it is designed to do something that sounds like a mistake. So why doesn't your road crack? The answer changes everything you think you know about weight, about the ground, and about what it means for something to last. Let's start with the ground. Because for most of human history, the ground was the problem. A cart would roll across a dirt track on a dry day and be fine. Then it rained, the surface turned to mud, the wheels sank, and the road ate itself. For thousands of years, this was just what roads were. Passable, then ruined, then passable again. Then, in 1816, a Scottish surveyor named John McAdam took charge of 149 miles of English turnpike. And he had one strange idea. He said the road surface carries nothing. His words, it is the native soil which really supports the weight of traffic, and while it is kept dry, it will carry any weight without sinking. Read that again. The ground carries the load. The road is just a lid. So McAdam built lids. Layers of small broken stone, packed down, each stone no bigger than could fit in a workman's mouth. That was the actual test. A supervisor carried scales, but the laborer on his knees just put the stone between his teeth. Too big, throw it out. The most advanced roads on Earth were quality controlled by mouth. And it worked so well that his name became the road. Add tar to a macadam surface and you get tar macadam. Tarmac. You are driving on a dead Scotsman's surname. But here is what McAdam understood that we forgot. He wasn't making the road strong. He was keeping the water out and letting the ground do the work. The road was never supposed to fight the weight. It was supposed to pass it along. Because the weight is the real enemy. And the weight is worse than you think. When your car rolls over the road, it barely registers. But engineers measure road damage with a brutal rule, and the rule is not gentle. Double the load on an axle, and you don't double the damage. You multiply it by roughly 16. It rises to the fourth power. So a fully loaded truck doesn't do a little more damage than your car. A single heavy truck can do the damage of 15,000 cars. One truck, 15,000 of you. And the road has to survive that in the rain, in the heat, in the frost, for years without being rebuilt. Modern engineers write that survival directly into the material. There is a grade of road binder called PG 64-22. It is a promise. It says this surface will not soften and rut when the road bakes to 64 degrees Celsius. And it will not crack when it freezes to -22. One material holding its shape across an 86-degree swing, while 15,000 cars worth of truck pound it from above. You have never once thanked the road for this. You have only ever cursed it on the day it finally cracks. But now we get to the strangest part. The thing that actually breaks a road is not the truck landing on top. It is the bending underneath. Every time a wheel passes, the road flexes. It bows down just slightly, and the very bottom of the asphalt layer stretches. Then the wheel moves on and it springs back. Down, up. Down, up. Thousands of times a day for years. And that is what kills it. The crack you eventually see on the surface did not start on the surface. It started at the bottom invisibly and climbed up to meet you. So you would think the answer is obvious. Make the road stiffer. Make it harder. Stop it bending. And that is exactly wrong. Because engineers discovered something almost unbelievable. Below a certain amount of bending, the damage doesn't just slow down. It stops. Completely. There is a threshold of strain so small that the road can flex and flex and flex forever, and never accumulate the fatigue that cracks it. They call it the endurance limit. And to stay below it, you do not make the road stiffer. You make the bottom layer more flexible. You let it bend more so that it bends softly, so that no single point is ever stretched hard enough to tear. This wasn't a stronger road. This was a road that gave up trying to be strong. They call it perpetual pavement. Build it right, keep the strain under that invisible line. And the surface can last more than 50 years without ever being torn up and replaced. Not because it resists the weight, because it bends just enough to make the weight meaningless. Stop and feel how backwards that is. We spend our lives being told that strong means rigid, that to last you must hold firm. And the road, the most used surface on the entire planet, does the opposite. It survives the heaviest thing we own by refusing to stand rigid against it. It lasts by bending. It fails only when we make it too hard. We call a crack a failure. We look at it and think the road wasn't strong enough. But the crack is almost always the opposite. It's the road that couldn't bend enough, stretched at the bottom one time too many, until the tear climbed to the top. The pothole you swerve around isn't the road being weak. It's the ground below finally speaking through a lid that lost its give. And engineers are now taking the idea one step further, chasing a road that heals itself. On a stretch of motorway in the Netherlands, they mixed fine steel fibers into the asphalt, so that when a machine rolls over it and heats it from the inside, the binder softens and flows back into its own tiny cracks and closes them. The road, warmed like a pan on a stove, stitches its own wounds shut. And its life doubles. So the next time you drive home, and the tires hum over that black surface without a single thought, remember what is actually happening underneath you. The ground is carrying you the way it always has. The lid is passing your weight along the way McAdam knew it should. And the whole thing is bending, softly, invisibly, a fraction of a millimeter with every wheel, so that it never has to break. You will never look at it. Almost no one ever does. But the quietest machine you own is the one you drive over every single day. And it holds you up by knowing exactly when to bend.